Okay, today we are uh what is it? What? Okay, so let's use this one. Temperature here. And I let's 3, right? Okay. Okay. It is here, right? Did I touch it? We didn't start. No. Oh, one. Oh, oh no, wow. So in two places. Never mind. And this one bring something. I actually save on. Okay. So so this whatever law, which law, is divided. Okay. It's Kirchhoff current, the um, does anything yet? The current law and this law, three branch. The carbon enter to be equal to having this node I2 I3. So carbon equal to carbon I3. Uh, coefficient sometimes the close loop, like the example we had in one of the chapter one. Okay, so this plus minus is 2 plus minus, and this is V3. Law is of all those loops should be equal to 0. So voltage, usually what we will look at is the current uh, entering minus V3. So the summation of all voltages should be equal to 0. So here, law. Okay. Last time we said that about Ohm's law. What if voltage resistance here? when this resistance is large, so to the resistor, right, it actually repel the current coming, right? Stop the current coming. So current here will become zero. But if you want to use Ohm's law, you can apply. It's very large. In Ohm's law, V over infinity, you get a zero. Is equal to zero. Equal to infinity, or it is an open circuit, a very big resistance here, it is the current equal to zero, okay, by applying Ohm's law. And more very are wire. So when uh set has a can flow to potential means also in a short circuit equal to zero. Okay, this is what we mentioned on what we call this uh, Ohm's law. Okay, by applying Ohm's law here and by applying Ohm's law at here. Okay, and current divider keep aside, and then Y delta also a part of this together. So we are going to do right now the okay. And having this sister resistance, this is you need to A cross section. Let me okay. So we are in second slide. All right. Now every resistance. So you need to expect that it has this large. Okay, this one. Then next, on the ideal voltage source, it says that ideally it will supply as much as it is. So it will supply, let's say, in real situation, it will not supply as it is 5 volt, right? It will have a plus minus 0.01 or 0.1. So you cannot expect that the ideal voltage source will exactly as in real situation configure this situation. Okay. The any the previous knowledge that you understand, when you want to measure a voltage, you need to have it across that source, right? Or maybe you want to measure a resistance, uh, then you need to make why? Because voltages are having the same voltage in parallel configuration. So you're expecting this one will be equal to this one, right? It is exact 5 volt, then it is 5 volt. So we need to say you have this one so that you only see. Okay, this 5 volt will have a plus minus 0.1. And maybe this one, 5 volt, is having plus minus 0.01. So if you say, so this is actually a trouble. If you okay, so what about this one? What about this one? If you have a 5 volt, in real situation, you have a plus minus 0.1. And V1 here, you have 5 volt, but a plus minus. In series, you can actually add them. So 5 here plus 5, you are expecting here a 10, right? But maybe over here it has some plus minus 0.1 and here plus minus. So you actually add them. I don't at all. A 10 plus minus or okay, so it's okay. All right. So it says that the current source cannot be connected in series. Why? Okay. Again, ideally we expecting this one to have maybe 1 ampere. And this one have this does not in current. Like it should have the same flow. So this there's a problem when it comes to real case. So when this has a plus minus one, here plus minus one. So causing you trouble in real case. So please avoid conflict. For actually at the level, single for one, stay at 1 plus minus 0.01. So you still have the not causing any problem when it is in real case. So do you have any questions? Current should have current when it is in series. Voltages, same. I think the highlight here is We need to understand what is series and what is parallel. We jump straight. Uh, a series of pen, sorry, pen. What is a series? When we one element next to it, another element. So we all what connected connect. Something in the middle of the note. Series. It's not a series. Okay, let me okay. All right. Those who are online, please let me know that if you cannot hear me or something. We are on slide number 5. Okay, so what is parallel? Look at here. Have something in between the side by side element. It is not a series. The series is the green one only. Okay. Yes, and then series and which one is in parallel for this configuration. Let me accept the one who came late. Right. Okay, so which one is in parallel? Color. Are they in? Yes. Oh, this. Yeah. I haven't. It's parallel also. It's parallel. Uh, two elements. Please connect it. The two elements. They are connected at the end. This is connected. All configuration. This is parallel. When you have this end connected and the other end connected, they are parallel. Okay, good. Okay, over the course, I will, because I saw that even though concept, they still cannot grasp what is series and what is parallel. Mana? Yeah. Okay. I thought there's someone coming in. Series and parallel. Series and parallel. Okay, what are the series parallel? Have okay. Mhm. Which one is in series and which one in parallel? RE, RB, RC, RD, RE. Okay, which one is in series? RE and RB? RD and series. Okay, series, RD, RE, yes. Okay, what others? RE, RB. Are you sure? Are you sure? One. Even though uh, there are exactly is this because we are looking from this side here. So that is not, and then disseminate A. So RA and RB, they are not in series. Okay, they are not in series. What about R? They are in series with RC, right? This RD and RE, they are parallel with RC. And then what about with VRB? RD with the whole thing here. Yeah, series. So if I write down in terms of equation, then here we are A, because series you can be parallel with the RC, parallel support. Then series RB, with series we RB. And then what about RA? Yeah, it is parallel with the whole thing here. So in terms of equation, you can write down uh, here. So RA here, RE parallel with the whole thing. RB, RB in series, right? With the whole thing. Uh, where you keep the these are RB. series. And then plus you are B or C. You heard it. Your stand should be equal to. Okay, okay, we have that resistor direct current through resist. This is a resistor. The current through resistor voltage drop. Yeah, this volt resistor of the current. Right? The current. Ohm's law. If you draw this current, you will draw like this. Let's look here then. You relate with what is the answer. But by looking at can actually the voltage to R. Something low, which is equivalent to okay. Can I ask you, can we have a negative point? Okay. This is the positive resistance, right? So, the resistance on the left. And we have by lines. 10. Was it? Not sure. 10. I mean, yes. So you have here, this is, and this is, okay. Actually, yes. By R or negative resistance. Chapter 4, later on. But then, when negative, don't rate. Because, okay, what if the current is okay. Yeah. So what if I draw current versus voltage? What is the slope? Slope. Hmm? Ah. So you need to play around with the Ohm's law, right? You need to place the current at a current voltage, bring it to the left side. The current uh, into V. And when you have this, slope is we call conductance. It is actually the G. And change the current. This is the conductance. We have the same make it equal. Decide into then it is a me. All right. So and another Yes. Okay. Then very important because on about lab to understand when plot current is equal to one of the R. That is different. Okay. Question? Okay. So conductivity of element is current reciprocal and it's zero or zero. So we have V which is equal to let me do right. So current is equal to 1. Or you can have it I into V over R by a V. When power is negative, what we call the power? Abs or supply. Supply. Okay, power is supply. It's an that's right. Uh, the consider giving equal to short circuit parallel to that. Okay. So for here, when the resistance is 2, we will have a plus 2. Okay. So I know from here plus 2 a very so just 1 second. You see again where we need to apply the short circuit and open circuit so that you guys understand really well. Okay, this one I think we can skip because it's already explained. These two. Okay, all right. Another thing that you can have network or circuit. And networks are composed of nodes, branches, and loops. So, loops. When you have a closed loop, it flows in you. But sometimes imagine that it is not actually closed, but you so that you maybe here or this you can okay, so okay, next element. So then so far the branch. Then so far. Passive element. Current supply, right? Also, what is the okay, that one is and the other one element is the source. Active element is passive passive and the what if we moving through by passive should have a plus on current entering a, a plus. What about current plus? Will minus sign for a node connected side by side like this. Okay, so you have one branch, another branch here. You have this one as a node. Or maybe you have one element here, another element at right. Between these two, there are a single point. We call it a node. We have three branches. Voice? Yes or no? Or three or more, right? Mhm. Oh, dia dah keluar. Ini tak keluar. Okay, go to this one. So, actually, to multiple. So, do this, but I2 is need to also call on this. It is entering sign, you should law. So, it is equal to the system is fixed. I get this. Bear in mind, if it is fixed, okay. Voltage, the current is plus sign. So you're having a what? It's a plus, so you, there's a plus here, and current equal to 1.61, right? So you can cancel it. 4, R4 is at here, R4. So what is R4? R4 is voltage of the apply from the current is moving. So you expect that have a same current. 3.38 UD and 40.43. The plus sign, so you have a 0.38. Okay, what about V2? V2 is here. Again, you need to be careful that you have a this side to the S61. Okay, now I to the K is like 8 kilo. 8 kilo. So it is entering a plus here. So voltage divided by resistor should have a 1.2. Okay. So it should have a By the way, the question will not be like this one. Very direct, right? So you need to actually find out maybe what's the current to here by having a ECL at one. Okay, so handling maybe right. This okay. You will either plus minus direction and so on. Then we have something like this, but a single note, a single note there. Look, is that close part? Do you apply this? Yeah. Looks and what is depending when you have a book. So say you have a six a book, particularly this is a book, then this is another book. Depending on the yeah. You know, the dependent notes. But see, when you have the here, dependent note. I can look sorry. Yes, yes, no, this and this. Oh, and the here, so okay, so theorem anyway is dependent notes minus less. Can you memorize? Okay, minus one. How many? Right, and minus very fun. Independent notes. So one here we have three independent notes plus no, actually three problem that the right figure at least and here then here it is uh, and here and here. Okay, so how many I need to write because this two branches connected side by side, you are having a one node. So you have three nodes. You're getting a number of easy. 1, 2, 3. Okay. So find the branch. Student always miss this point as a node. Node node is as is the there. First, you can also have, so can I ask you, dependent Okay. In the independent. Information. Okay. Any other guess? 1.23 plus E 1 and 40 plus 2. And 7. Okay. Let's go to the question we already touched, right? Uh, okay, this is for the save it, but actually save to all across folders. So I'm not sure why. Oh, okay. On chapter 2. All right. So how many branches we have? That you have? Okay. So 1, 2, 3, 4, 5, 6, 7. That's 7. And then what about notes? 6 1, but can you see that 4 notes? Also written over them. So let me, okay, right. Then one note connected. Another note connected to 4 branches. Is it 4 branches connected to this? No. Can you see it? 1, 2, 3, and 4. Right? So it has 4 branches connected to that note. Another note. This is 2 branches. We have 4. Okay. Notes are there. Notes 4 is 4. 3, 4. What about the note? The 1 here, 2 here, 3, okay, 3 and 4 here, 5 here, and 6. So it's actually a 6. The 10 is plus this 4. Okay, this is this is number of. Okay, done it. Any question? Can we verify with the theory? Next one. So the loops is the independent loops, which is only 4 plus. Yes, that's good. Okay, again, either you have all the current loops equal in the loop, or the summation of. So which one you like? Have it on this, then you got either this one, either in the note, in the note. And do the calculation. Current law. But oh, by the way, also this is the order. So you can current entering the photo currently. So like here, I3 equal to current living, which is I4 plus I2, and equal to in the power field. Very good for your super mesh letter in chapter 3. Please to understand, we're going to apply this in simple math. So, figure out how many branches actually is boundary. One branch, third branch, and fourth branch. So you have four over there. Four elements need to be added equal to 0. Okay. Okay. Between 3 or more is the uh, definition of essential nodes. So it says that when 3 branches connected at a single point, 3 or more, let's say you have 1, extension. Okay. So please each ascension node in the circuit. I ask me try again. See someone already going to sleep. Any try? Can have one? Oh, usually they one time. Give the ascension node number 1. Maybe I give number 1. You do the rest now. I want current entering should be equal to 6. Summation of current in equal to alpha. So current in, ada is current in. Going in. Identify which. I6 is going in. Yes. Then I3 is leaving from here. And current is leaving. No, one is going from. No. Yeah. Yeah. In. Current in. Current in is I6 now. And? So which is that? You already draw. This is current in. Okay. This is current in. This is current out. You just I3. There's no name. But it is a current or the current source or current source, right? For that current source. 5 maybe. Yeah. 5 yeah. Okay. Please do no equation, but just avoid that because you might confuse yourself later on. So I do not want you guys to please back and feel not please. Okay. Anyone? Note 3. Person. Okay. Anyone? Sekejap, saya tengok je Note 3. This one. Stay in the corner. Oh, nobody. And they don't get that. But it is recorded, so I just want you, those who miss the class, they can still go back today. Let's try, and then we can point out whether you understand it or not. But to try, you don't want to try all this. Any one of it. Okay, identify which one is current in the node. Number 3, oh, current in. Number 2 or number 1? Number 2. Okay, number 2. Number 2 is basically on this part. We have a highlighter because we do. So, it's yellow. This is a current in. Yeah, current in. And this is also current in. And then we have a current out. Current out. Okay. Current out. Okay. So currently, I see which should be equal to current out. So that's why we have it entry equal to I6 plus 5 milli. Why we do the 5 milli? Because this is a value of the supply. So what I you don't understand. Oh, okay. But but you just need to look at the direction of the current. This one is the direction of this current here, and I think here. Okay. It has it for I3 here, so that we need the current here. Can someone try grade 3? You want to try? You can highlight which one the current is going into or current is going out. No? So highlight it so you can change it. Highlight the current in first. This one. This is the highlighter for color yellow. You just identify the color first. Current into in, another current in. Yes, good. Current out, you change the color. One purple. Okay, good. Now you change to pen. You can write the equation. Current in, line in, okay. Last with current in, another one, like 3, okay, good. Go to current out. Yeah, I want plus the current out, the purple color. 5 milli. Don't forget the milli. Usually students will forget the prefix. Prefix milli. You make your handwriting. Okay. All right. Ampere, please remove that. Please remove ampere. Yeah. Okay. Okay. Thank you. Okay. Do you guys get the is this a series or not? Yes. Is this a series or not? Yes. That's the point. Okay, that's good. I thought everyone very clear. You see it very well because maybe for me it is more than 100 times I see it. Maybe it's a great, but for you guys are first and fundamental, right? So you guys need to try and need to understand it in the class. So please remove any unit in your equation, including in your quiz, in your assignment, in your okay. So do not place NP or voltage whatsoever. Ohms. No. Please avoid that because you're going to spend more time. And last, at the end. Okay. Next. Question? Summation of all voltages around the closed zero. So, and this is clockwise, so it is entering a minus sign. This current is sign here, going into V1, which is a plus sign, going into V2, it is a plus sign, and going into a V2, a minus sign. So you have a equal zero. So let's try this one. If tiba-tiba dia dah jawapan. Okay, this one. Apply KVL to each loop in the circuit. We have one or maybe more. You can have loop number one here. We have two, so three. And we have later on, I'll give you loop number four, number six. And we try. Anyway, one try. One. The other section I go very fast because of the you understand. Right, it seems that they do understand. Maybe I need to go back to the example because I didn't charge. Okay, anyway, this is the time you use the pen. Okay, volunteer. Number one, KVL. No need to click anything. No. Just apply. Number one, it says that you have a, maybe the loop is this way. So it is having a minus 10. So the number one, it is minus 10. And then going into a minus here, minus, and then going into a plus V8, plus V8. And in this one loop, you equal it. That's okay. Number two, oh, I should not place it like this. So maybe this is um, like this. So number two, anyone? Maybe I should mind the number, the pardon? What do you do? You place which round? Counterclockwise or clockwise? Which one you like? Okay, if you want it like that, all right. So what is the equation? Is it 8? The voltage. The voltage law is the summation of all around the loop. The resistance current. Summation of all voltages around the loop. Okay, can you for entering a you can draw. Okay, for VR. Oh, okay. Can you highlight? Okay, I have plus basic. Finish all three elements. Plus what? What plus 8? 8 is a resistor. Yeah. So plus B 8. Okay. What? 0. Yeah. Very good. And this one you need to. All right. Anyone else? Volunteer number 3. Number 3 here. Okay, anyone? Yay. Number 3, you choose what direction you like. Yes, PI. Okay, good. Yeah. Bigger so that do something silly. Yes, okay, good. Right. Plus, equal to wrong. Yes, without equal to, it also your equation will be wrong. Yeah, thank you. Very, yes, very good. Okay, what about the random loops? What is number 3? We highlight random loop. Number 3. Mm, This is number 4. Anyone? Often. Yeah. We can write down often. Yeah. N plus 6. Good. And it to make it logic. Expand yes plus have only 4 elements, right? Yeah. So you need to add it with equal to 0. All right. Why we have it? This is a voltage. You need to have a formula. It's PN, like PN. Okay. Only the loops, the closed loop. That's not the question. Okay, now we go to 5. Can you try? 5 here. And make it. So this is 5. And prepare number 6. And all the loops. Up to this. Oh, right. Okay. And this is a pen. Up to it. It's a 4. Okay. And then plus V3, just I want to highlight to the rest of the class. That one is a minus V4. Equal to 0. Yeah, there's more elements in the closed loop. Very good. Thank you. Okay, the last one. To have the last one. I like it. So we have this one, number 6. Maybe you will write down here to 6 here. Start from 4 and minus V4 plus V3 plus plus 2. Yeah. Then then please remove any unit. Later in your quiz, maybe place a unit there, device. Okay. So, okay, very good. Okay, this is the looks at the here too. Uh, 8%. Okay, do we have that? Okay. Guys, we set the current direction clockwise. So if we start from this BA, this is about this BA here. So let's a minus. So and then it's a plus here. And then B, B, and B2. So not the resistance. And 3 will be 3 and 3 equal to 0. At the current apply the own resistor. This. And the resistor, the current of plus current. So current is section of your plus here. So your plus for the second one equal to current I. So you have and the T3 is apply 3 into this current. So equation rearrange have the current VT, we got the summation of current or resistance. Okay. Current loop having this. Okay, very good. So this is the solution. What about if I do have okay. Hmm. Why? Fine. I do. Is that the question? Fine, we do. Right. So this have can make it and another using this of the this one you should do this one yeah. Okay, here I I plus this and plus V2 into V2 and they ask is 6 and VI. And here you should the 6K is having up and this is here and the current 5 me. So by looking at plus right. So plus and your current is into and really you have V2 2 plus this here. Plus the current maybe there. So equal to 5 2. This is 10. And this is a. Or about the last PI. So you substitute into the equation. You have 30 here. You have 50 equal to. This is a minus, right? So I make it to the right side. So the rest is so 30 plus 10 is 50. Oh, all right. So for this side, that part, do we have another somewhere? It's already there. Do we have time? Maybe I make note here. I should give you a try, tapi because we don't have time, so let's just do it here. This is red color kan. So here it is, and here and minus B6 plus I equal to 0. Okay, what about the resistor of each? We have a V2 minus plus B6 is moving of that current. So you should have 5 U, and since a minus equal to and the current is minus 5 milli, you should have the kilo and have a 10, right? Kilometers. And what about V6? V6 uh, minus plus speed is minus it's opposite direction of the original one. Then the V6 is equal to, you have a minus here, so please write down the minus. And you have a current, which is a minus 5 milli. And you have this, and you can remove, and this is the remove. Okay, from this, you have VI and everything else on the right side. I, then plus this. This one plus this one. But like I said, different approach, you will be having the same answer. Yes. Ah, 5 minutes. When we get it from here. Uh, this is a current, right? This is a current. No, so what is this? Still. Okay, this is a has the value of 5 millimeter. But since our direction is the direction, right? Minus 5 minus 5. Okay, can you try for your book? So we end our class with the speaker power as for the others. On Wednesday will be online. I think we can do the physical part, but the engineering actually don't give permission. But I want to be here actually because it's easy to write down. So let's see. Can end the class then. Yes, so in our class with the speaker power and so the others. Okay, thank you, class. I need to close this part.